Hey Lex. All right. So I called my geo guy and we talked through these two problems. It wasn't just us. He even was like, wow, those are some mega problems. But we argued a little bit about what was right and what was wrong, but ended up coming to a consensus. Um, so here is the first one. Let me just hold on one second. I want to make sure that I have the actual problem in front of me. All right, so this was number 5. Um, and we're trying to prove that triangle TRS is isosceles. So I'll just do this. Okay, so that's our goal. Um, so here was the first thing that I kind of said when we were meeting. The the picture that she gave you like kind of throws you off. It's not drawn to scale. So what it's actually going to look like, and I'm just going to draw it what it kind of should look like, and I think that will make understanding this a little bit easier. Um, is this. So let me just try to make this as nice as possible. We have P, Q, R, S, and T. All right. Um, and I'll just do the proof over here. So, one of the first things they tell us is MN, I believe, yes, is congruent to MO. And I'm going to run out of room, but I'll try to make this as neat as possible. I'll also send you a picture of my written one, but I just wanted to explain this. So basically what that tells us is really important. It's telling us that this side of the big triangle is the same as this side, which then just automatically tells us that this bigger triangle is an isosceles triangle. And if we know that, let me go back to black, this whole side is the same as this side, then we also know that these base angles are congruent. So that's going to be step 2. You're going to say angle N, sorry, my handwriting sucks, is congruent to angle O. And this is just going to be isosceles triangle theorem. Okay, but that's going to be important as we move forward. The next step is one that they give us. So this was kind of a weird one too, because usually you put both givens at the front. This case, I didn't think it was best to, and neither did my geo teacher. So then the third step would be, we're going to go back to the information that they give us, which was Pn over Ns equals Qo over OR. And again, that reason is just given. They gave it to us in the beginning. But so basically this is saying we have this triangle here, right? Or because we have Pn is here and then Ns is here. And then we're comparing it to QO, which is here, and OR, which is here. And now if you're looking at those two triangles that we just kind of talked about, so it would be like PNS and QOR. Okay, so it's saying that this side is proportional with this side is proportional with this side, and we found out that these angles are both the same from the bigger isosceles triangle. So basically, you have here, and I'll do this in a new color, you have a side, you have an angle, and you have another side. So what we can kind of jump to is this. We can say that triangle PNS is congruent to triangle, and I'm running out of room, QOR. And the reason we can say this is because of that side angle side similar triangle theorem. Okay. Again, we got the side part we got from step 3 with the ratio. The angle part we got from step 2 with the isosceles triangle theorem. Now that we've proved that these small, medium-sized triangles, I guess, are congruent. Let me try to. I hope I have another color. We'll see if yellow looks good. Then what we can do is talk about angles R and angle S. Okay, so if you look at the medium triangles down here, we can say that S and R are congruent because, let me just write that for a second. So we have angle R is congruent to angle S. And the reason we can say that is because we just proved that those medium triangles are congruent. So thus the corresponding angles are also going to be congruent. So this is where that corresponding angles of congruent triangles are congruent. And then, voila, if we can highlight this TRS here, I know it's getting a little messy, but basically what we just proved is that R and S are those base angles. So we can go ahead and jump to what we were supposed to prove, which is that triangle TRS is isosceles. And so we kind of disagreed on this. I would write out, I'm going to try to write this the best that I can. I would say that base angles are congruent. And then I would say definition of isosceles triangle. He basically said that you could just say definition of isosceles triangle. I would just add in those base angles are congruent part because I think that like ties in the whole proof a little bit better. So that is the first one. I hope I explained that decently well. We can definitely go over this the next time that we meet. I think so. This one I was able to kind of come up with on my own, and then I just double checked with him. So this one was a little bit more doable. Basically, this next one, we both were just like, oh my God. So this, I'm not sure that you were prepared for based on what your teacher had taught you. And there's a couple of theorems that I like didn't even remember existed. So let's do that one next. So I'm going to clear this. Actually, you know what? No, I'm going to go to a next frame and then I can send this to you. Okay. Let me get myself situated here. So the first thing I'm going to do is just draw this thing. So we have a big triangle. It's kind of like this. That's a terrible triangle, Ava. We have this, and then we have this. And this was J, H, G. And then we had M and K. All right. Okay, and then what they told us was, actually, I'm going to put this in the proof. So the first, because this is the first step anyways. So they told us that, let me see, G, J over HK is equal to GK over GM. And they told us that angle G is congruent to angle HKM. And this was just given. All right. So the kind of what I got tripped up on was this proportion up here. We actually don't need that until much later in the proof. So really what we should just do in this first part is say, okay, well, jangle, oh my goodness. Angle G is congruent to HKM. So that's actually right here. Okay. So basically, what you have to see from the very beginning, and I'm going to try to make this as neat as possible, is that this triangle that I just traced is isosceles. if you kind of turn your head to the left and look at it sideways. So that's like the key. And I didn't see that at first. So because I was too focused on the proportions. But this right here is step 2. So just simply seeing that triangle GHK is isosceles. And again, so I'm going to put this up here so I have room, but he basically just said that you could just say like definition of isosceles, but I again would say base angles are congruent, and then I would say definition of, sorry, this is supposed to be a period. I don't know what I'm doing, of isosceles triangle. So that's like the game changer right here, seeing that there's this isosceles triangle sideways. All right, then, so I'll get another color. We go with the isosceles triangle thing. So we know that if these two base angles are the same, then this leg and this leg of this isosceles triangle are also congruent. So that's our next step. So we go step 3, and we can say line segment HK is congruent to line segment GH. And again, it's really just kind of like definition of isosceles. But I would also say, I would say legs of isosceles triangle are congruent. And then again, definition of isosceles. Okay, so, okay, now this next part, this is where this is like a crazy, crazy problem. So I'm going to do this next part over on the side just so you can kind of understand it a little more. So, basically what we do, so we go back to this given up here, right? So remember I said we kind of like forget about that for a second? Well, we go back to it now. And so I'll write this. Originally we had GJ over HK equals GK over GM. All right, well, in step 3, we basically said that HK and GH are equal to each other. All right, so what you do is you're going to actually substitute GH for HK, right? We said they were equal to each other. So what we can actually do now is rewrite this as GJ over GH. Okay, so instead of HK, we're saying GH because we proved that they are congruent. Equals GK over GM. And remember I was saying, I was like, this is so weird because when you're looking at GJ and HK, like those lines aren't even on the same triangle, right? So I was like, I wonder how that, we're going to use a proportion for that. Well, this is called the substitution method. And that's actually how we kind of solve that. So because we know that HK here is equal to GH here, we can substitute it in the proportion. And that's going to give us information that we need. So this step is actually just going to be GJ over GH. And I would circle this just so she knows that you know what you're talking about. Over GK, or I'm sorry, is congruent to GK over GM. And this is just simply called substitution property. That is supposed to be an S. There we go. Substitution property. And again, like this is what we substituted right here, this GH. It was HK in the given. We substituted it to GH since we proved that they were equal to each other. And then this is a killer, this last part too. This was a theorem that I was not familiar with. I don't know that she taught you this. I didn't look back in your notes, but I didn't recognize it. Basically, we're at the last step, which I think is crazy. we can say that HM is parallel to JK. And that theorem is called the converse of the side splitter theorem. Okay, and I'm going to try to explain this a little bit. I just did some research on it. Sorry, that should be an E. Okay. So basically what the side splitter theorem says, and you can Google this too, it says that a line parallel to a side of a triangle divides the other sides proportionally. Yikes. Okay, so basically we're talking about HM here. Okay, so when we, in step 4, kind of substitute the GH for HK, what we're doing, and I wish I could get a different color, but what we are then able to do is say that, okay, well, this part, GH, is, and this part, GJ, those are proportional to GM and GK, right? That's what we said in step 4. And basically what this side splitter theorem is saying is that if you have a line that kind of splits those proportions, right? So if you see like this line kind of starts right where HG and GM start, and then this line down here starts where GJ ends and GK ends. Basically, it's saying that that proves that those two lines are parallel. Because it essentially like splits the proportion on both sides of the triangle. So on like this side and on this side, HM splits where the small side, they're the small part ends, and then JK kind of splits where the long side ends. So yeah, like I said, that one's really messy. I think that there was a lot of things that you just had to see from the beginning, and then you had to know about substitution property, and you had to know about this converse of side splitter theorem, which, like I said, I didn't look back to see if it was in your notes, but I know that we didn't really talk about it when we were doing tutoring today. So, oh my God, that's a lot of work. I'm going to send you this video, and I'm also going to send you just pictures of my work so that you can also just see it a little bit more clearly. I know this was kind of messy because I was trying to like show you on the diagram, but I hope this helps. And, if it makes you feel any better that you weren't able to do it, it took 2 math teachers to sort these out. So they were definitely difficult. So good luck, and I will talk to you soon.